All right. So let's just do some examples of that, right? Oh, sorry. Notation, right? If f and g are functions, okay? If f and g are functions, then a composition is denoted like this. Okay. So f, like almost like an O, but it's like not quite an O, and it's in like the same position as like a multiplication symbol would be, but it's not a filled in dot, it's like a hollow dot kind of thing. Okay, FOG like that. That would equal f of g of x. So g substituted, plugged into f, right? And of course, then if we wrote it the other way, if we had g o f of x, that refers to then g of f of x. Excuse me, like that. Okay, so that's the that's how you denote. That's how you might see it denoted. Sometimes we just use this, right? But sometimes you see the FOG like that, and a GOF. All right, let's get into an actual example here. So given f of x equals 2x plus 3, and g of x equals 5x plus 4. Okay, so there are our two functions. And let's go ahead and use those then to find f of g of x, and then we'll also find g of f of x. Will these be the same thing? We're using the same function, but in a different order. So do we expect these to be equal to each other? Something to think about, right? All right? We'll see. All right, let's do f of g of x, which means we're going to substitute g of x into f, right? G gets plugged into f. All right. And again, depending on how comfortable you feel with this, you can take, more or less steps. I'm going to take it step by step for this very first one here. So g of x, right, we know is precisely 5x plus 4. So I'm going to replace g of x inside of f with 5x plus 4. Okay, just direct substitution there. Right, but now we want to apply f to the quantity 5x plus 4. So in f, we know f applied to x does 2 times that x and then plus 3. So here, f applied to 5x plus 4, we would expect it to be 2 times the quantity 5x plus 4, and then plus 3 again on the outside like that. Okay, so kind of like what we were doing earlier when we evaluated functions, we are sometimes doing compositions as well. Okay, simplified out, we get what? 10x plus 8 plus 3, which is then really 10x plus 11. Okay, and so that would be like our simplest form of our answer there. All right. All right, let's try this other one here. Then number 2, right, we're going to see then, does g of f of x equal the same thing? Using the same functions, but in a different order here. Okay, so now we're going to do g of f of x. Replace f with 2x plus 3. And so again, we're going to apply g, we're going to apply the function g to 2x plus 3. G applied to just x is 5 times that x plus 4. So g applied to 2x plus 3 will be 5 times the, bless you, 2x plus 3 plus 4. And then we'll distribute, so what, 10x plus 15 plus 4 equals 10x plus 19. So they're close, kind of, right? But they're not the same. Okay, not the same. Thank you. Okay. Yes, Julia.
If you were to find the inverse of a function and put that in, would that probably fit?
Yes, and we'll see that next. We'll see that tomorrow. Actually, we're going to talk about inverses, right? Yes. So yeah, but yep. Inverses will be a different story. So let me give you guys another. Here, this is for you all to try. Okay, so try this one. All right, so given h of x is equal to x minus 2, g of x is equal to x squared minus 4x plus 1, find h of g of x and g of h of x. Okay. One is going to be super easy. One will be a little more work, but not that much more, but a little bit more. So if I'm looking here, right, so when you tab this, it substitutes in place of the x. You put x to x. Place x. So just substitute in. So g of x is this. So replace g of x. G of x is inside. G of x is x minus 1. So you replace it. G of x is this. Now you're going to take this thing. You're going to go to h. Replace x. Replace this. Minus 2. I get it. It's not for everyone. The 4 is going to distribute. The -4 is quantity times quantity x, so it's going to distribute. So I think that might be. Yeah. So watch that. I understand the right.
No, it's x minus.
Only old women are like, oh, it's too long.
Well, I guess I could be considered an old woman.
I guess so.
Is that correct? Yes. No, I will say it's so strange because, like, I don't feel like I am the demographic of the show, I would say, but, like, just looking at the channels, though, I would like see them just enraptured by, like, the amount of dialogue passing between the two of them, and it's just like, and that's what, like, was, like, drawing me in. I don't know what it was, but it's just like,
I like it. No, like, yeah, you would never think you'd watch it, and then
Yeah.
you finally watch it.
Yeah.
You know, I have to.
yeah, and like the drama and stuff, I'm like, whatever. But just like the listening to them talk and just like, whoa. Do you know the show that the person that has that show, that ran that show, she's got a new thing on Amazon. Yeah, I'm trying to think of the name of it. I'll look it up and tell you though. But it's supposed to be like, I like watched like a clip of it, and it was like pretty comparable, I would say, to it. So, did you watch the Netflix episodes of it?
The new ones?
Yeah.
Not yet.
Okay, because on Netflix they have like a new season or whatever kind
Yeah,
of thing.
yeah, the revival.
Yeah. Yes. What's that? Gilmore Girls. Don't judge me. It's fascinating. Anyway, I think. So there are your answers.
That is so good. I love it. Every single time I go to
There are your answers. Okay. Questions on any of that? We're all good? Okay. Cool. So let's do just a few more here because I think I got, yeah. I just want to do like one more here and then I'll have you try one more and then we'll be done. Okay, we're not going to do too much today with that, but just want to make sure we're comfortable with this composition stuff. Oh, I'm sorry, yeah. Okay, all right. So let's see here. Okay. Bless you. So we can, in addition to like composing functions, we can also like evaluate composed functions as well. So as an example here, let's say we've got f of x equal to the quantity or root, square root of the quantity x squared plus 9. Let's say g of x equals then x squared plus 2. And let's, you can't see that? Oh, there we go. Okay, and then let's find g of f of 2, like so. Okay. So option 1, you can compose the functions if you want. You could find g of f of x, then plug in 2. Okay, that's your choice. My recommendation, though, is to find f of 2. Okay, find f of 2, and let's just say that equals some value a, and then calculate g of that a, which is equal to then g of f of 2. Okay, so you can find f of 2, whatever that is equal to, right? That, let's just say it's a, and then find g of a, right? Which would then be the same thing as finding g of f of 2. So again, if we just kind of follow that here, so step 1, and you can kind of see it in the order here, right? Just do f of 2. What is f of 2? Well, we'll type, do f of 2 equals the square root of 2 squared plus 9. Okay, so it's going to be the square root of 13. Okay, no plus or minus necessary here, right? The square root is already given to us. It's a positive square root, right? There's no sign in front of it, so we know it's positive square root. We're not doing the square root to both sides of an equation or anything like that. We're not in an equation setting. It's a function here. Okay, we're just evaluating. So this is just root 13. No need for plus or minus. Okay. Then step 2, g then of f of 2 will be equal to g of, well, what's f of 2? root 13 or square root of 13. So we can just replace that f of 2 with the square root of 13. Which then that square root of 13 will now replace the x we have. So it'll be the quantity root 13 squared plus 2, which is then 13 plus 2, which is then 15. Okay, the square cancels out the square root. We add 2, get 15. Easy peasy. All right, so I'll give you one more to try here, and then we'll cut you loose on the assignment. Or maybe give you some time to work on that 10 marks if you haven't finished that up yet. Okay, so they're your new functions, m of x and n of x. Right, very distinct letters, m and n. Find m of n of 3. And then if p of x equals x plus 3, find m of n of p of x. Okay? So there you go. Give that a try there. Please. That's fine. Yeah, and that's Matt, you got an answer for us there for m of n of 3? 45. Sounds good to me. Okay. Okay. Thank you, Matthew. And how about Cooper? You got an answer for us for m of n of p of x?
Not currently, but I can get it.
All right. Let's hold off, and I'll come back. We'll give you another opportunity another time here. I want to make sure we got it. Gabby, do you have an answer for us for this one?
No.
Nope, that's okay. That's okay. This one was a pretty complicated one. Lots of ins and outs. You know, how about Rebecca?
4x squared plus 28x plus 45.
Okay. I believe that's what I got, so, I mean, hopefully that's right. All right. Any questions on that? All right. Cooper, you just needed more time.
I don't know what how do you get 4x?
How do you get the 4x squared part? Okay. Let's take a look. So real quick, we're going to do p of x. That's going to get plugged into n. Okay. Actually, I'll just do it on the screen here. So this is m of n of p of x. P of x, actually, this is going to be harder to do it that way, I think. So let me just take p of x and plug it into n here. So it'll be 2 parentheses x plus 3 plus 1.
Okay, yeah.
So far, so good. Which then gives us 2x plus 6 plus 1, or 2x plus 7.
But isn't there a square? It will each square the x plus 3.
We'll get to that. All I'm doing right now is just doing n of p of x.
Okay.
N of p of x. And then I will take this, which is what n of p of x is, and I'll plug that into m. So then it'll be 2x plus 7 squared minus 4.
Okay.
Follow? You okay?
Yeah.
And so then when you square this, well, it's really 2x plus 7 times 2x plus 7 minus 4. So you get 4x squared minus 4, or sorry, plus 14 plus another 14, so plus 28x plus 49, but minus 4, so plus 45.
Okay.
All good?
Yeah.
All right. Gabby, you're okay too now? Okay. Any other questions? All right, cool. So your homework is on Google Classroom. This time there is both a small book assignment and a worksheet as well, okay, to work through. And then, of course, if you haven't worked on your TenMarks, I suggest you work on that too, especially considering you might have questions that you're not going to be able to necessarily ask otherwise. Okay. So please do get started on that assignment.